I just wanted to show you guys the different allotropes of carbon. Allotropes, remember, are same element, same phase, different arrangement of the atoms. And you saw it already on the slides that we talked about this morning, but I just wanted you to see the models. This right here is graphite, and if you look at it this direction, you can see all these six-membered rings. And remember, these are alternating double bond, single bond, double bond, single bond. But also notice that they're two-dimensional sheets that pass by one another about a 328 picometer distance is about right there. And picometer, remember, is 10 to the minus 12 meters. And so I mentioned that since there's alternating double and single bonds, that gives a pathway for the electrons to travel. That's also true in the connections. There's weak forces that connect the two layers, but that also gives a path for the electrons to move up and down throughout. So that's kind of interesting. Remember, it's a black powder. It conducts electricity. It's got a little bit of shininess to it if you did, in fact, see a crystal of it. Usually it's kind of in a powder. Because of these sheets, the layers will slide past one another pretty easily, and so that makes it feel really smooth. If you were to take some pencil lead, because it's not really lead, and go like this with your fingers, you would see that it kind of slides past one another pretty easily. This is carbon diamond. Look at how complicated this is. It's very hard. I can push on this, and it really doesn't collapse at all. Obviously, if I pushed really, really hard, I could beat this plastic model. But obviously, we all know it's the hardest surface known. You can cut a diamond with another diamond, that's about it. And again, remember these were sp3 hybridized carbon atoms. They're all attached to 4 other carbons, and they're really solid and strong, and it's a covalent network. Both of these are covalent network solids. They look really different. And as I mentioned, there's all these faces. All these different faces are what reflect the light and give it a beautiful shine. This is called buckyball. I didn't really go over it this morning, but it's in the slideshow, and it's also in the other audio. But the interesting thing about buckyball, if you were to count all these vertices, there are exactly 60 of them. It's exactly C60. It looks just like a soccer ball. You've got 5-membered rings and 6-membered rings. Go ahead and look at the stitching on a soccer ball. You're going to see the same thing. It was named after a guy named Buckminster Fuller, and he was an architect, designed the geodesic domes, which are like truncated icosahedrons, which is very much like what a buckyball looks like. I can take my hand, because there's a large cavity, and I could stick my hand inside of it. Well, imagine on molecular size, you could stick potassium atoms or potassium ions in there, because they're going to spit up an electron. You could fit 3 in there. If I lower the temperature down to about 18 degrees Kelvin, you end up with a superconductor. And so that was kind of the first time that anybody had ever seen superconductors made out of carbon materials. That was a pretty big deal. But it resembles actually more like graphite. It's sort of a black powder as well. It's an insulator at room temperature, though, and you could only get it to superconduct if you dope it. And usually it's doping it with something that's in the 1A. There's my periodic chart in the 1A column. Last but not least are the nanotubes. There's lots of different kinds of tubes. This looks like a big, huge hot dog. If you look at it closely, you'll see there's 6-membered rings, 6-membered rings, 6-membered rings. Not till you get to the ends where you'll see some 5-membered rings. Okay? And I guess when they discovered the buckyballs, they were like, well, if there's buckyball, maybe there's something else out there too. And they usually are in multiples of 60. So like this one's twice 60. This is C120. There's some C360s. There's lots of different ones like that. Okay, those are the allotropes of carbon.